Hello, I'm JW. This time we're continuing with the CNC series, and last time we saw it was drilling those holes in the base, and then those threaded inserts could be installed in there. And in order for it to do that, it was necessary to provide it with a list of instructions, and those instructions are in the form of a program, and that's written in G code. And it's called G code because most of the instructions in it start with the letter G followed by a number, so hence it's called G code. Now in theory you could just type all the commands in manually, but in reality nobody does that because it's far too difficult and it would take far too long. So in most cases you're going to be using some other software to create the program, and the software we're going to be looking at today, which was what was used for that, is called Fusion 360. Now there's a load of other software out there as well. Apart from that, it's certainly not the only choice, but it's the choice that we're using here. And unlike a lot of other software, it's an all-in-one solution. So it has a part where you can actually design the part or component or whatever it is you're actually going to be manufacturing, and then it has a second part where you can actually create the G code or whatever for the particular machine you're going to be using, which in this case was just drilling some holes, but it can also create code for a whole load of other machines, so mills and routers and lathes and all kinds of other stuff. Now Fusion 360 is available from autodesk.com, and go there and have a look if you want to get details about it. You can get a free trial version to use, and in fact the full program is actually free to use in some circumstances, so again go and have a look there if you want to get details of that, and if not then you have to pay a certain amount for it, and the normal version costs around £30 a month or something like £300 per year, so not a huge amount of money, but nevertheless various options are available. There's also another version available which is far more expensive, which has a load of features in which we don't really need here. So what we're going to do then is just have a look at the basics of it and how that program was created, and that starts with designing the actual base of the machine in the program. So let's start by having a look at that. Now what we've got here is Fusion 360, and this is the default view when you've just opened up a new project or whatever on the side there. Now the first thing we need to do is to actually draw the base of the machine, and this is essentially just a rectangle. It's basically a sheet of melamine faced chipboard. So we're going to start by going up here to the left, and we're going to pick a rectangle because that's what the machine is, and this guy's going to do a center rectangle. And now we have to pick which plane we're actually going to draw this on, and we've got a choice of 3, as this is in of course 3 dimensions. So I'm actually going to select the base here, and we'll see it will actually just move into that automatically. So this is actually the XY plane, because of course the thing is on the base of the machine. Also the Z is the vertical in this case. Now for this rectangle I just need to place the centre, which we're going to place here at the centre of the origin. So we'll just click there, and then we just drag out, and we'll see then we have a rectangle. Now we can actually type in the sizes here, so the sizes we want in this case, the height is actually 740 millimeters, and then the width of it is 1110 millimeters. So just press enter there after entering the dimensions, and we can obviously zoom out and see we've got our rectangle. And see the edge is actually black, which means it's now what's called fully defined, which means we've actually specified the actual dimensions of both sides. If it wasn't black, then it means we haven't actually done that yet. So 740 that way, and 1110 in the other direction, and that's basically the size of the base of the machine. And in order to find out the size, you just get out a tape measure and actually measure the thing. It really is as simple as that. Now there's 3 other elements I want to actually draw in here, which are the support, which go across the ends here, and also in the centre. And those are also rectangles. They're actually strips of steel which go all the way across to support the base. Now these are also rectangles, so we can draw those in with rectangle as well. So you got to rectangle there. And in this case we'll just put 2-point rectangle, and this will allow us to line this up with the one we've done already. And if we just move in at the top left corner here, you'll see that blue square will appear, and that means it will then snap to the corner that we've already got. So again we can just click there and move down to the bottom, and we'll see here that it's got a little cross on the bottom, which means again it's snapped to that particular position there. And as before we can type in the dimension. Now of course the vertical dimension is going to be 740 because that's the width of the table that we've already drawn, so we just need to do the actual dimension across here, and in this case it's actually 60 millimeters, so just put in 60 and we'll press enter, and then that's defined the first one here. Now we need to do the same at the other side, so that's just on the right hand side here. So we're just going to do the rectangle, so 2-point rectangle, snap in at the first corner, and I come down to the bottom here. And as before, the height of course is 740, which obviously we've seen previously, and then we'll just type in the width of it, which again is 60 millimeters, and that's created the one on the end. And then the one in the middle we need to do, and this is actually centered in the middle here, so again, because we started the other one in the center, we can do likewise with this one. So again, we'll go to rectangle and use the center rectangle again, and again we'll start in the center obviously, and then we'll just expand out, and again the width of this is going to be 60, and you see the height is already 740 because we basically snapped to the top line. So again, just type in 60, press enter, and then we have the 3 pieces defined there. Now that's actually it for the base of the machine, so click over here on the side panel and just put stop sketch, which essentially will finalise what we've actually done there. And it's zoomed in rather a bit, so we'll just zoom out. And so this is the base of the machine, it's the rectangular top piece, and then we've just got those additional 3 rectangles which define where the pieces of steel are underneath. Now of course in reality the bits of steel actually extend beyond the base here. That doesn't matter because we're not concerned with that, and of course we could in theory model up the rest of the machine as well, but again we don't really need to do that. Now of course at the moment we've only got a flat sheet, so we need to add some thickness to this. So we need to basically extrude this to the thickness of the base, which in this case is 20 millimeters. And to do this we're going to use the tool, and we could actually go up here and find it, but the keyboard command for this is actually Q, and so it comes up here with press pull. And it says selection, so it's asking us basically to select what things we want to extrude. So we're going to select this one, and in fact we're going to select all of them on the bottom because they're all basically connected. And then we can just pull on this little thing here, and that will just move it upwards as required. And again we can just type in the box here the precise distance we want. In this case it's 20 millimeters. Press enter, and there we have our base plate, which as you can see is now got some thickness to that. And if we just rotate that, you'll see that there it is, basically 20 millimeters in thickness, and of course the size that we defined earlier. And we can also look underneath as well if we wanted to, and you'll see it is centered on the origin there which we started from initially. Just click the little home thing up there, that will go back into the place like that. Now the next thing we need to do is to put some holes in it, so we can of course drill the holes in. That was the whole point of actually doing this. So what we need to do first of all is draw one of the holes, and holes are round, so we can do a round circle, and that's actually C on the keyboard. So if we just click on there, and then if we actually select the object in question, so we'll select that, it automatically goes to that particular view there. And if we zoom in a bit here, we can actually draw the circle just by clicking here and then just dragging, and then you see we just adjust the size. But we know it's going to be an 8mm hole, so we can just type in 8mm, and then we have our 8mm circle, which we've just drawn on the top there. Now at the moment that's just an 8mm circle floating about in the middle of nowhere, so we need to specify exactly where it's going to be located. And if we go over here to the left, we can turn on that sketch that we had previously. We can just see that peeking through underneath. So if we now press D for dimension, we can click on the circle and then just click on the edge of the actual material, and then we get this dimension thing showing up here. We can position it wherever we want, so over here will do fine. And the distance we're going to want here is actually going to be 90mm, so type that in and press enter. And the reason for 90 is that the piece of material is 740 wide, and if you do that up into 80s you get a certain number across with 90 at each side, so that'll make it nice and symmetrical on the other side. And then we need to specify the dimension across here as well, because again it's just floating there. So again we click on the middle, and because we turned on the sketch we did earlier, we can just see it showing through from underneath. So click on that one, and again there we've got our dimension here. And in this case we need to type that in, and it's going to actually be 10mm. and see it automatically moves into position. And the reason it's 10 is because we want these at 80 spacing, so we have a 10mm space here. This piece we can just see underneath is the 60mm wide piece of metal, and then when we put another one on the other side it'll be 10mm there, and then that will give us the 80mm between and avoiding drilling into the metal piece. So that's the end of that one, so we can just click on Stop Sketch over there, and then that just goes back to what we saw previously. And if we turn that on, we can just see there's the little hole we just drew, and the various things underneath we drew previously. So that's all working as you would want. Now, of course, that's only a circle at the moment, it's not actually a hole, so if you go and look at that, you see it is just a circle on the top, there's no hole involved there. So we need to make that into a hole, and we can use the Q command again, or that press pull, so just press Q, just like we did previously, and if we go in there, then just select on the circle that we made, and now we can actually turn this into a hole. Now, the arrow is actually for the direction, so if we scroll in there, we don't want to pull it upwards because that's basically the wrong direction, so if we go down through the material, now we could just leave it at -20, as that's the thickness of the base, but if we go up here to the panel on the side here, it says extrude, we're going to start at the plane, which is basically on the top where we drew the thing. Direction is one side because we're just going in one direction, and instead of having distance as extent, what we can actually do is put all. And we could have also used, in this case, to object, but we'll use all, which means it will go all the way through all of the objects or things that it finds in the way. So that will automatically go all the way through. We don't have to necessarily type in the dimension itself. Now in this case it doesn't matter at all because we've only got one, but if it was a more complex thing which had dozens or even hundreds of different components, by specifying that, then if we change the dimension to say the thickness of this, then all those holes would update automatically. We wouldn't have to go in and amend them individually. Operation at the bottom is cut. There's some others there which we're not using here because we basically want to cut the hole through it. And the objects to cut is basically the thing we're cutting, which is this body one which we made earlier. It's the base of the machine. So we can just click OK there. We can then turn off the sketches because we don't really need those because we've done with them. And now the circle we had is now actually a hole, so if we zoom in there, you'll see there's actually now a hole that goes all the way through. And if we just rotate the model there, we can see through the hole to what's underneath. And if we look at it from underneath, there's the hole going all the way through. Now one hole's all very well, but we need a lot more of them, and we could draw them all individually and align them up carefully, but that's going to take far too long. So press S on the keyboard and then we can search for a pattern command, and we're going to pick rectangular pattern. Now it's obviously a rectangle, and then we get the pattern box up here. Now first of all we need to select what we're going to make a pattern from, or the object, so in that case it's going to be that hole we just made, so just zoom in a bit and pick the hole. And in terms of these, this is how far apart they're going to be, or in other words the space between them, as we've got spacing here, and then how many we actually want. We also need to select the directions we're going to go in, so we'll just say that direction and this direction, as we want two directions. So we're going to go for the spacing as we had before, 80mm, that was also the whole point, and we'll go 80mm in that direction. Now it starts out with 3, and we'll see that these are actually going in the incorrect direction here, so rather than 80, we'll just change that to -80, and you'll see it goes in the other direction. Now I'm going to leave that one at 80, but if we change the other one in the side box here to 80, it will then go across the plate like that. Now we need obviously more than 3. Now this thing here, by the way, and these up here are basically the same. You can just do it there or up here, it doesn't actually matter. So we need to increase the quantity that we have. So for this one we'll just turn these up a bit, and you'll see it will just expand the pattern across the grid. We want to go as far as we can without going right to the edge, so that particular one is going to be 8, like that. Notice that says one direction on both of these. Now that's fine for the direction here, but the other one we can change to symmetric. That means it goes on both sides of the starting point, so when we increase that one, see, it will fill in on both sides of the grid like that. Now that's pretty much all we need there, so if we click OK, then we can see we've got holes now all across the grid, and if we have a look from the top view there, Now we can see it's a nice rectangular grid of holes, all spaced out and aligned as we would expect. And if we turn on the sketch again, we can now see that the middle is obviously avoiding drilling the holes there. It's just nicely spaced either side, as we put the correct spacing for this hole in before, and that's been basically duplicated across to all of the others. We can see all the holes there. Now there is a bit of a problem here, because at this end we've got a whole row of holes across the top piece of the metal, and it also happens that the machine can't even reach that far to drill them, so we need to actually get rid of those. So if we go down here to the bottom left, we can just click here and put edit. Now because we've got suppress selected here, we can actually just untick the ones that we don't want, so we'll just get rid of a load of these, as we can't drill there because it's obviously solid metal. And we'll actually take out these two rows as well, mainly because the machine can't actually reach to that position, because the gantry is of course one-sided with the spindle overhanging. So we'll take those 3 rows away, but obviously we'll leave all the others in position so that it will fill up that spacing. And we don't want to go any further to the right here, because if we did, again it would be into that metal area, which of course is what we want to avoid. So click OK there, and then we get our holes in a more sensible place. And we can turn off the sketches now and then just see the whole thing as it's finished. And if we zoom in there, we can of course see that they are in fact all holes going all the way through. And if we look from underneath, well, there's those holes again. So that's the thing we actually want to make. And although that took quite a long time in this video, in reality it wouldn't take very long at all, because all you're doing essentially is drawing a rectangle, extruding it to 20mm, drawing a circle, extruding that through the material, and then just making a pattern to copy the hole all over the thing like that. So the next thing is to actually set up the machining parameters for this, and if we go to the top left here where it says model, we can then change to the cam option down here. And you see there's quite a lot of other options in here, things we're not currently using. So we'll just click on that. Looks pretty much the same, but the difference is on the left here we've now got a whole load of different things, and this is where we're going to set up for the actual machining process. So the first thing we need to do is create a setup, and if we click here where it says setup, we can go to new, and as it says there, it just defines a number of general properties. So we'll click there, and then we get this box at the top here where we can select various things. Now operation is going to be milling. We could have turning or cutting or whatever else, but we don't have plasma cutters or lathes here, so milling it is. And then we need to actually select some kind of origin point here, so we can then define basically which direction is which. In this case Z is correct, but Y and X are actually the wrong way round, so we need to attend to that. And we also need to select where the actual origin or 0 point will be. Currently it's in the middle, but we are going to want to be moving that to down at this corner. Now if we go to the stock tab up here, we need to change this, because what we actually want is a fixed size box, and the box is going to be the exact size of the thing which we're making. So in this case 1110 by 740 by 20mm. The other ones are useful if you're going to say make a part and then cut parts off of the starting stock, but in this case we want it to be the exact thing, and then we're drilling holes in it, so fixed size box is what we want. Now for the origin we need to set basically where the middle of this thing here is, which is currently in the centre, but we need to actually locate it to this hole. The reason we're going for that hole is it's easy to measure from the edge here and here on the actual machine, so then we can easily locate it there accurately. So rather than model box point, we're going to put selected point, and then we can actually go and select. I have to zoom in a bit there. We can actually select the hole there which we made earlier. So just select there, and then that will basically become the 0 point. So we can actually line the machine above the hole and flat with the surface, and then that becomes our 0 position. Again, that's quite easy to get because we can just simply measure from the edge here and the edge here on the actual machine, and then all the other things will be referenced from that. Now model orientation is actually slightly wrong, because though Z is in the vertical direction, Y and X are the wrong way round, so we can change that from orientation here, and then of course just select the appropriate options. So I've just changed the arrangement there, so basically X is going across the table, which is the moving correction, and then Y goes along here, and of course Z is in the vertical direction, and you can do that just by selecting the edges and whatever in there. And post-process, we don't have to really put much in here. You can put a program number in there, 1001 will do, and the rest of this doesn't apply, so we'll just click OK. So now we have our piece of base here, which is part of the machine in this case, all the holes there, and this is the start position, basically 0, 0, 0, and we've got our 3 directions going in the correct places, so X over there, Y along the longer length here, and of course Z is the vertical direction. Now the next thing we need to do is to pick some kind of machining operation, and there's a whole load of these up here, 2D, 3D and so on. And in this case we're going to pick drilling because obviously we're going to be drilling some holes, so just click on drilling there, and then we get another one of these things over on the right for drilling. And just as with the other ones, you've got various tabs here, and you just start on the left and work across and work down each tab. So first of all we need to select an appropriate tool to actually do the drilling, so we just click on select here, and this will open up the tool library, and inside there's a whole load of sample tools and all kinds of other stuff, but I've already got one in here and a drilling demo. I put this in earlier, and basically it's just an 8mm diameter drill, and if we just click on that we can then see the details over here. Nothing particularly spectacular. It's made of high-speed steel, it's just some generic thing. It's 8mm in diameter, and then we've got various things like the length of the actual drill bit and the shaft and how many flutes it's got, which is 2 in this case, angle of the point, and a whole load of other stuff in there, most of which we don't really apply in this case, and the type of tool holder and all kinds of other stuff. And there's a lot of tools that come with Fusion 360, and you can obviously add your own in there as well, and even download them from various manufacturers, but this is just a generic item. If you just double click on this, we will just select that, and you can say edit your own tools as well if you want to. So that gives us the drill there. Coolant is disabled because we don't want any coolant. This is a piece of chipboard we're drilling, so we don't want any coolant flooding, and the machine hasn't got it anyway. And then in here you've got the various speeds, so the speed of rotation is going to be 3000 RPM, and it's going to plunge in the material at 900mm per minute, and some of these are also calculated from the others. And these are actually set up in the tool parameters, so if we actually go back to that tool, and if we edit tool, then we can see in here that it's all defined in here already, and so this is just basically a generic 8mm drill which I picked from the library that was there already. So you see it's now put the little drawing of the tool on the model we have there. Now moving on to the next tab, which is geometry. This is basically selecting what it is we're actually going to be drilling. So we've got the thing we're going to drill with, now it's a question of what are we going to drill. So nothing is selected at the moment, which of course is useless, so we need to select something. If we zoom in a bit, and we can just pick one of the holes. This hole will do for a start. Now we could just go and click all the holes individually, but surprisingly enough that takes too long. So over here we've got where it says select same diameter, so if we were to just click there, then it automatically selects all of the holes of the same size, which in this case is all of them because they're all the same size. And you've got some other options here as well, so most of those don't actually apply here. Optimize order is turned on, so you see it's going to start there and do these in a fairly square pattern, and then for some reason go over here and then finish there. Not entirely sure why it's put that long move in like that, but anyway. If optimize order is not on, then it may well just pick some other weird pattern, which is certainly far from optimal because it's going to sort of go and dodge about here and do all kinds of weird stuff, although that's not actually too bad. One I had previously was literally, it looked like a complete pile of spaghetti. But optimize order should put it in a more sensible arrangement. The previous video, actually, when it was drilling, had the option of order inside out turned on, which means rather than starting at one edge and working across, it starts in the middle and goes around in a sort of circular pattern. It doesn't quite work because it's square, but you get the idea. And that's just an option we've got there. And we don't need the other options there, but so moving on to heights. Now this specifies the various heights that the drill is actually going to be at, and we've got a whole lot of these down the side. Now if we start down at the bottom here, the bottom height, in other words where it's going to drill down to, is essentially the bottom of the hole, which is not too surprising. You see a little diagram there, and in this case we actually want it to go through the bottom of the hole. We're going to add a little bit of an offset there, so we're actually going to put here 2mm, and if we put that in there, it will actually go through the bottom of the hole, and we can see the little diagram here. So you see there, rather than just stopping at the bottom of the hole, it will actually go slightly through the hole just to make sure it's completely cleared through. Now it's fine in this case because again we've got a spade under the table. Obviously wouldn't select that if there was something else or another component underneath. So that will just go to the bottom depth and then just a couple of millimetres further to make sure it's cleared through and makes a reasonable hole, or fairly tidy on the base there. The top height is unsurprisingly the top of the hole, so that's where we want to start drilling in. And then some of these others here, if you just put the thing over, it tells you where they are from. The feed height is essentially where it goes to before it starts plunging into the hole, and that's actually 5 millimeters above. And the retract height is also 5 millimeters, so that's basically where it goes up to before it moves to the next path, as it says there. Now in this case most of these don't actually matter because we're just drilling into a flat surface, so there's no issue with it colliding with the other items, but if you had a more complex shape or with 3D things on it, then you would need to make sure that that was above the height of anything else on the table, otherwise when it moved it could smash the drill bit into the side of some other feature. And then the retract height is where it goes to when it's moving at a higher speed. So most of those we can just leave as they are, and then moving on to the final tab, which is cycle. And then we have some different types of drilling here. We've got drilling rapid out, and again if you just put the mouse over this it will tell you what all of these actually mean, so you can pick those. In this case, we're going to take deep drilling full retract, which if you look on the left there, it says retracts completely out of the hole to clear chips and or flood the hole with coolant. And the deal with this, if we just click that, we can then say that it's going to go into the hole to a certain distance, then it will come out of the hole, which will clear away any of the chips, which in this case are going to be shredded up chipboard, and then it will go back into the hole again to complete the hole. And if it was a very deep hole, it could do that several times, avoids it being clogged up with chips and things inside. Now we're only drilling through chipboard here, so it's probably not necessary, but I did set it anyway in the other program that we saw previously, just to make sure that there was no danger of it getting bound up or stuck in there with anything it's drilling out. So on this one I actually set the pecking depth to 15 millimeters, bearing in mind we're doing a 20 millimeter hole. So basically it's going to go into about a depth of 15 millimeters, pull out again and clear the hole away, and then go in and do those last 5 millimeters to go through the bottom. And also remembering it's going to go through an extra couple of millimeters we set on the previous tab just to make sure it clears right through the bottom and make sure the hole is all the way through. And we don't need the other items here. We could obviously select if it's going to sort of stay in the hole for a period and then come out, but that's just adding time, so we don't need that. So we're at the last tab, so we can just click OK, and then that has now created the tool path which will drill all of our holes. We can see this in action by going to the simulate thing up the top here. Let's click on that, and it's now drawn in the representation of the drill and the thing it's going to be installed in. If we just click on the play button at the bottom of the screen, then you'll see it will go around and give an indication of what it's going to do on the real machine. And you can adjust the speed as well. If we just crank that up a bit, it goes around a bit faster. That's obviously much faster than it's going to do it in real life. And as you see, it then gets to the end. Just slow it down a bit there, and comes to the last couple of holes. And that is that. And then eventually it does return back to the couple of holes on that side, and then it's finished. So that's right, through the middle out it's not quite circular, because obviously when it gets to the edge the circle isn't quite right because it's rectangular. But anyway, you get the idea, and if you have a look at the other video you'll see how that worked in practice. Now while it's actually doing that, you'll see at the bottom of the screen here there's this green strip, and the little black thing is its current position. If you see any red bits in the green strip here, then it means it's colliding with something, and you will definitely want to go and change that before doing it on the real machine, because if it's colliding with something it means that the tool's going to get broken off, or the machine's going to get damaged, or something similar is going to happen. I mean, in this case there's nothing to collide with, but if you had, say, a number of complex shapes and other things here, it will actually detect whether the tool is going to mash into something you've already cut, for example, and it will show that at the bottom in red. So a very handy feature to actually do this, rather than go to the machine and then find out it's going to mash into something as the tool is smashed into some component and the spindle is broken in half. So that's pretty much there, so we can close the simulation bit there because it seems to work as expected. And then the final step is to actually create the file which is going to be taken to the machine. So in the actions hole here we've got post process, and it says there converts it into the code that we want, and that will open up the panel we've got here. Now there's quite a lot of options in here. The top one is basically where the configuration folder is located. You can obviously change that if you want to. And then in the selection here we've got a whole load of different things to pick from, and there's a lot of these basically for different machines from different manufacturers and all kinds of stuff in there. And the one we're going to be using here is the Mac 4 mill, and this was not actually included with Fusion 360. You'll see there's also in there for Mac 3 and even Mac 2 as well. But if you can't find what's in there, then all you've got to do is click here where it says search for posts in our online post library. So just click there. That actually then goes to the website, as we can see here, and then it's just simply a question of downloading one of these as appropriate. And there's quite a lot of these in here, so for different manufacturers, different types of machinery, and all of kinds of things like that. So in this case it was the stuff in Mac there, and it was the Mac 4 mill that we used, so just a question of downloading that and stuffing it in the folder, and then we can use that one. And it says generic milling post for Mac 4, and post in this case means a post processor, not a bed post or something similar. So that's all we've got there. Then we can choose where it's going to save the file. In this case I'm just going to stick it on the desktop there because that's just easier. Program number you can change that to whatever you want, so we'll just leave it as the default in this case, and you can put comments and things in as well, so no problem with that. And there are some other options in here, as you can see in the side there, and we're going to leave all of those as default as well, including G28, which we'll get to in a moment. And then all we've got to do basically is press post, and that will generate the file. Just asking where to save it, so it's on the desktop there. We'll stick that there, and then it will actually open the file as well, so we can see what's inside it. So here's the file it's just created, and there's that 1001 at the top. Basically anything in brackets is basically a comment, so it's just for reading purposes. So in this case it's program 1001, and this then defines the type of tool we're using. So as you can see, that's a drill diameter 8, 118 degree taper, and various other factors in there. And then the actual code starts on line 3, and you'll see here why it's called G code, because there's the first command G90, and I've got G94, and so on, and then that just goes down there. That top part is basically a bit of setup. The G28, G91, Z0 is essentially retracting the spindle to the maximum height, which in this case is 0, because bearing in mind if it's at the top it's 0, and then as it moves down it's negative. That basically puts it to 0 for safety, so that it puts it right as high as possible first before moving it to the location. That avoids it smashing into things and breaking stuff. And down here then we've got the spindle being turned on, which is this M3 S3000 line. A lot of these here have to do with coolant being turned off, which we obviously don't need anyway. And then it's setting it to the various coordinates here, and then the drilling part is actually this line here with the G98. So that line there is the actual drilling operation, and then that is basically repeated for all of these coordinates all the way down the list here. So the drilling thing is only in once because it's the same for every hole, and it just then repeats that for this position, then this position, and so on, all the way down there, until we get to the bottom when it basically cancels that. And then we've just got the bit at the end there just to, again, retract the spindle to the highest possible position, return to the 0 position, and then obviously end the program and turn off. And this is basically the code you would just take directly to the machine and shove in there, and this does the job. So that is essentially how the entire thing works. And I say, though this is a fairly lengthy video, it's quite quick in reality just to design that up and do those things, because of course when you're not describing stuff it's much quicker than actually describing every single step. And of course you would normally save this in the appropriate place there. Just click save, and then you would just give it a name. In this case we'll just put drill demo, and we'll save that. And all of this is saved in the cloud, so you can access this from other computers as well if you needed to. And the whole of this thing works on your personal account, which you can see at the top here. And you can actually go to your account online and see all of the files you've saved and all of that. And then this thing here is to just where things get updated as and when features are changed. So when it comes to actually using that file on the machine, what we need to first of all do is to position the machine at the origin, or the 00 point. That uses the limit switches on the machine, and that's around here somewhere on the actual machine. I've already put in the machine the other dimensions of the table, so it knows as far as it can actually move in the various other directions. And then we just move the spindle to the 0 position here, which is the location of the first hole, and in the video that was actually marked with a green dot. I just basically measure that with a ruler, and the end of the tool then just needs to rest directly on the top of the surface there. So we've got the machine coordinates, which are over here somewhere, the sort of physical limits of where it can move to, and then we're setting the offset, which is basically this point, as the 00 for what's actually being cut. And if we have a look at the code again there, the reason it's got this strange line here with G28 and G91 is that although we've set this as 0, when you've got those in there, that Z0 is actually referenced to the machine itself, so that is literally going up to the mechanical stop of 0, and then it's moving to the first hole, which in this case is in the middle, and then it switches back to the other coordinate system, which is the one that's based from this point here. So essentially it's moving up as far as it can physically go, and then it just switches back to the coordinates starting at this point of 0. Although that seems rather confusing, it just means it can go up literally as high as it physically can. So when it moves at high speed across the table, it doesn't have any danger of smashing into things and breaking off. And if we look at the end of the file here, we'll see again it's got the same command there again. So again, it's going to the highest Z position it physically can. So then that's using the machine coordinates rather than this position here. And then it does the same again to the X0 and Y0, and because it's G28, that will come right back here. It will not end where we started out with the thing sort of basically graunching on the top of the table. It will actually be here, fully retracted as high as possible, and at the 00 position, which is obviously convenient. Then you can remove the tool and do whatever else you need to do with that. So that's pretty much it for this time, and so this was only a quick brief overview really of the way that this was created. Fusion itself has a vast amount of stuff in, which is far more complex than that, and of course we may look at some of that at a later date. But until next time, thanks for watching.